Ladies and gentlemen, floor is yours. Chapter 3, Section 1 and Section 2, Exam 1 review sheet. What questions do you have? Yes.
Can you just I don't know, I was stuck on trying to what to do. You don't think some numbers to do, just giving an outline.
Okay. Yes, our process is going to really be two separate initial value problems. So let's start with the first one, right? The first one starts when time is 0. Our skydiver throws himself out of a plane. What is his starting velocity at that point in time? Right. Step out of the plane. My initial velocity is 0. Great. So at time 0, V of 0 is 0. The only other thing I know is the force exerted on the diver, right? So the total forces. I got to go back to physics class. Oh, I'm going to scare you. We're going to do a point diagram. Here's my skydiver falling. What is causing him to fall downward? Okay. And the force due to gravity is? That's the acceleration due to gravity. What's the force?
It would be that times 160.
Right. We'll get the numbers in a minute. But it's mass times gravity, right? What force is pushing up? Because as this person falls through the air, there's another force. Our drag force, force due to air resistance, FR. And all we are told in the book is that this is using the model in problem 37. Oh, so that means that this is some constant times the velocity. Now, according to problem 37, I know force is mass times acceleration, which is mass times change in velocity. I have velocity right there. Both of those things depend on t. I have a model that says mass times acceleration is equal to mass times gravity, take away the air resistance. That formula is provided to me in problem number 37, yes? I'm a sneaky booger, it's right there.
Yeah.
Okay, wait a minute. I'm going to put this on the other side, and I'm going to divide by m. So far, so good? You're given this constant.
Yes.
You know the mass of the person. You know gravity. This is a linear differential equation. We wait 15 seconds. We write out the solution to this problem using this initial condition. At time 15, tell me how fast they're going. I don't know what that number is, but you're going to use the equation you get from solving this to give me that number, right?
Yeah.
Now, at 15 seconds, boom, oh, shoot. And what changes? The drag, K. I'm going to call this V15. I don't know what that number is. But now I have dv dt plus k over mv equals g with a new k and a new initial condition, don't I? Now I can solve the equation a second time. And when I do that, I'll get the speed that they are now floating down to the ground gently with, right? So now I have a piecewise defined function. It's whatever the answer was for this from 0 to 15, and it's whatever the answer is to this from 15 on, until they hit the ground. But we don't want to know about when they hit the ground. We do want how long does it take them to hit the ground, right? I want to know the time when the height is 0. I want to know what their speed is at 20. I want to know what it is compared to their terminal velocity, how fast they would have been if they just kept falling. And I can get all of that by letting t go off to infinity in our solution, right? That'll give me my terminal velocity. And then, I think she's covering 15,000 feet. Threw herself out of the plane at 15, so we know how far she's got to fall. We know when she's going to hit the ground. Go ahead.
It also asks how far she traveled after 20 seconds.
Okay.
So is that just the integral? They take the integral from 0 to 15 and add it to the integral of 15 to 20.
Because distance is the integral of velocity.
And also, when I get the new equation for like the 15 to 20, would I do from 0 to 5 or like?
Okay, now that's a good question. Because if I use v of 15 for this number, then I would go from 15 to 20. But I could rescale and say I'm going to go, and instead of t, I'll use x, which is t minus 15. And then I'll go from 0 to 5. But it's your call as to which way you want to do that. If you leave it as 15, then you go from 15 to 20. If you reset this and call this is now v0, then you go from 0 to 5 in this new equation. Does that make sense, that rescaling idea? I'm going to show my age again. The movie called Point Break. Keanu Reeves is a cop dealing with a guy who is a thrill seeker and a bank robber. And one of the things he does is he throws himself out of a plane without a parachute. To catch the other guy who's already jumped out of the plane with the parachute, he tucks himself up to make himself fall faster, minimizing his air resistance and his drag, and then they argue over the parachute in midair. It's a very, very, very weird fight scene. But it's amusing in a very weird sort of way. It's worth watching if you haven't seen it. It's a bad movie from the late 80s, 90s. It's not a great movie, but that scene always makes me, this problem makes me think of that scene. More questions. I'm sorry, Mia, better? Okay. The numbers suck.
Stuff, so it's just the one. Yeah.
Yes, there are a lot of integrals in there. Yes. There should be 3, I think. More questions. Ask me more things.
Game review.
Yes.
You do number 4.
If you can tell me what the problem is.
By dx equals, this is a fraction, top of fraction, x times x squared plus 1
X times x squared plus 1
over 4 y cubed, comma, y zero equals -1 over the square root of 2.
Okay. Given the fact that the right-hand side, that fraction that you're talking about, is something in x times something in y. Only in this case, we're using division, right? This is separable. If I cross multiply, 4y cubed dy equals x squared plus 1 dx. What happens when I integrate?
That's y4 plus inside. And get 1/3 x cubed plus x.
What about this extra x on the outside?
Oh, you have to do so.
Or you can multiply it in, your
Yeah.
choice. But yeah, you can U sub or you can multiply it in.
X,
Plus,
uh, x squared.
or you'd get 1/2 x squared plus 1 with another 1/2 because you would be 2x, right?
Yeah.
Okay. Now, normally I put the c on the x side rather than the other side, so I'm just going to move the c over for the moment. But notice that if you do this, you're going to get a different value of c because there's already a +1 in here, and there isn't here. Okay, so now I need to put in my initial conditions. Y of 0 is 1 over the square root of 2, so 1 over square root of 2 goes here. Sorry, -1 over root 2 to the 4th plus c. Zeros go here, so I get 1/4 of 0 plus 1/2 of 0, which is just 0. Which gives me 1 over the square root of 2. Well, I'm raising it to an even power, so I no longer care that it's negative. That's square root of 2 to the 4th. So that's 2 squared. So that's a 4 on the bottom. So I get a 4th. So c is -1/4. And my equation is y to the 4th minus 1/4 was 1/4 x squared plus, sorry, 1/4 x to the 4th, 1/2 x squared. If you move the 1/4 to the other side, well, then it works out really, really nicely because this is a perfect square. Factor out a 1/4, and this is 1/4 x squared plus 1 squared. And that's y to the 4th over on this side. Did it say give an explicit solution, or did it only say give an implicit solution?
It's explicit.
Okay, that means I need to get rid of the 4th power. What do I do when I get rid of that 4th power? I mean, we can leave it like this if you want. We don't have to have it in that form.
It doesn't.
But what do I do?
You have to take this for both sides.
So it's a 4th root of all of this stuff. But when I take an even root, there are 2 choices, right?
Yeah.
So is it the positive root or the negative root?
Positive, but
It's got to be one or the other.
positive.
Why?
Because all value all values in there, even if they, so even if there's a negative X, it's still positive.
Yes, but that's not the reason I use that. Matter of fact, I don't want to use the positive square root, I want to use the negative square root. Look at our initial condition. Our initial condition up there says that when we put in an X value that is 0, we get a value that is negative. If I put 0 into this, I'm going to get the fourth root of 1. I need to make that negative. So that has to be a negative here because of the initial condition. You're welcome. More questions? Jack? Immediately after class tomorrow. You hand in the homeworks, I post the homework keys and the review keys at the same time.
I just, a little small question, going back to number 40.
Uh-huh.
When he opens the parachute, if that's within his mass, it'll be 160 pounds.
Yes. Because the mass includes the chute, which is in the backpack. And then it's still attached to him.
Yeah,
Right.
I didn't know if like that.
No, I understand exactly where you're going. He left something out, right? Shouldn't it be less mass?
Like, pulling him, like it's
But it's still part of the mass that's being pulled down by gravity. If I were to change the mass and the velocity at the same time, I'd really need two different differential equations, which we'll get to later. But I want you to understand something. What's something that actually gets lighter when you use it? Let's think of a vehicle. Soap definitely gets lighter the more I use it, right? But something that changes with my velocity. If I'm in a car and I start flooring it, what happens to the gas? I burn it up and shoot it out, don't I? If I'm on a rocket ship, I have all my fuel with me and I burn it up and throw it away to make myself move. I change my mass and my velocity together. Related differential equations is a big part of what we will eventually be doing and is a much more realistic model. And guess what? That really means you get to do rocket science in this course. All right, hit me again.
For 3.2, number 2. Because of two conditions.
Yes.
But in class, I feel like we only use one condition.
So
Because when I get the answer, it works for n of 0, but it doesn't work for n of 1.
So tell me how you got the answer with n of 0.
When we did in class, where like like I plug basically everything into the equation empty, and the initial would be 500, and then A is also 500, and E is 1 over.
You sure about that? See, this is my problem. We actually have a carrying capacity given to us in this problem, right? What is our carrying capacity? But we're told in this case that it's 500,000, right? Sorry, 50,000. If I set A to be 500, then B is 1 over 100, right? But I could just easily have used, 1,000 and 0.02, couldn't I? Or 500,001, right? It really could be any number. I just put this is a capital K. This is a little k. So I just put another number in there. But what is our equation for P of T? The way we wrote it up?
A minus B. And then that is equality times e to the negative at plus b times b naught. Well, that's not the b times b naught is in the exponent. It's just fixed.
Like that?
Yeah.
Right, because it was +1 and there were parentheses, and then we distributed it out.
And there's parentheses around a minus b times.
So if I use these numbers, you're right, we're going to get something that only works at P0. I want something that works for P of 1 as well. And that's where this number comes into play, this extra factor of K, because it will allow me to solve for that growth rate. Because that's the piece here that's the problem. This is very much the same as the idea in example 1. Only this is our screwball piece because we don't actually know the right numbers. I just know their ratio. And that means I'm going to end up with an extra thingy in there. Yes, sir. Uh-huh. No, in order to be so we use linear in 2 different places. We talk about a differential equation in terms of the functions of y, right? The first equation we were looking at with the falling person in problem number 40. This is a linear equation, but it's not equal to 0. It's equal to whatever this number is, because the thing that is multiplied by our derivative is a 1. The thing that's multiplied by our v is also a number, not a function of v or v prime, right? So linear in that setting means that the coefficient functions are not containing y's. Something like this. And I've written this disgusting, right? But all these are a bunch of derivatives, right? the highest derivative with some function that's only in x. The next highest derivative, some function only in x. All of these derivatives are never multiplied by each other. There's no function of y multiplied by another function of y. There's no e to the y or cosine of y or anything like that, square root of y. And then this thing over here is all x's. Hang on, let me write. dy over dt equals. That is not linear because I could write it as t times y to the negative 1. That's not a derivative, is it? Right, that's my problem. It's not linear. But it is separable. I'm sorry? Oh, good. This is again where my pattern matching is going to come back to me. Can I see a separable? Can I see a linear? Can I see an exact? Can I see something close? Maybe a substitution will help. We had 3 different kinds of substitutions in that one section on substitutions. So I'm hoping all of these things are going to be useful to me. Excuse me. More questions, ask me more stuff.
Here's number 10 on example 103.
If you'll read it to me, I'll give it a shot.
And determine the order.
Okay.
Solve using an appropriate substitution. The equation reads x dx plus y minus 2x dy equals 0.
Okay. I need to know if it's homogeneous, and if so, what's the order? Homogeneous means I put a t where I see a tx and ty where I see x and y. So this is m, this is n. Tx is the same as t times the quantity x, that's t times m. Ty minus 2tx is the same as t times y minus 2x, which is t times n. This is homogeneous of order 1, because that's a t to the first in both cases. Whew. Okay. When I'm doing homogeneous, I'm either going to use x over y or y over x. I know there's a method by which I can choose which one to substitute. And I always forget what it is. But I think it's you use whichever one is easier, whichever one is simpler. So I think I want to make the substitution for x. And so I'm going to write down my substitution as x equals uy. I don't know if it's supposed to be u or it's supposed to be v. It doesn't really matter. With me so far?
Yeah.
Okay. If that's my substitution, then what's dx?
Y.
Ah, these are products. So I'm doing it as product rule. So this is u dy plus y du. because u is now another function. Okay, I'm going to put that in for x and I'm going to put that in for dx. So my equation becomes uy times u dy plus y du plus y minus 2x. I don't have an x anymore, I have uy dy equals 0. So far, so good? All right, let's see if I can gather all of my y's and u's and all the appropriate pieces. I have u squared y dy plus uy squared du plus y dy minus 2uy dy equals 0. Nothing seems to cancel, but I'm okay with that. We'll put all the dy parts on one side and all the du parts on the other side. So u squared y dy plus y minus 2uy, all of those are dy's, right? And then the only du is this one, minus uy squared du. Hey, there's a y in every part of this, yes? Let's factor it out. What's left behind?
Squared minus 2.
U squared minus 2u plus 1. On the other side, minus u y squared du. All right, the u is over here, the du is over here, the dy is over here. So let's make all the y's go to this side and all the u's go to that side. Y over y squared dy equals minus u over u squared minus 2u plus 1 du. If I want to integrate on the left side, I can rewrite that as 1 over y. But over here, I have to yank out partial fractions again. The denominator is u minus 1 squared. Partial fractions, that's a over u minus 1 plus b over u minus 1 quantity squared. And then I have to do partial fractions over on that side. When it's a repeated thing, it shows up more than once in increasing order of power.
Wait, why is it u minus 1, u minus 1 squared?
Because this is to the second power, right?
Yeah.
So either it's got to be au plus b over u minus 1 squared. But it's not au plus b, right? I'm missing some stuff up here, aren't I? So in order to make this work right as a u sub later to do the integral, I need to split it up and put it in there repeatedly. Common denominator. So I get au minus a plus b. So according to this, a must be equal to -1 to get minus u. And if a is -1, there's nothing over there, right? What's b? Well, now I know how to do this. This is the integral of -1 over u minus 1 minus 1 over u minus 1 squared du.
You go over that A plus B part again?
Sure. This has to be equal to this. The top of this has to match the top of that. So AU is equal to minus U, and minus A plus B is equal to 0, because there's no constant term up there. This tells me that A is equal to -1. This tells me that B is equal to A, so B is equal to -1. You're still looking at me like you hate it.
Yeah, I think I'm just still confused with the A plus B, like how you first initially like wrote it. Like,
Okay.
U minus one squared.
Okay, so this is something that bites us in the ass back in chapter 7 in the Calc 2 class. It does it all the time. Whenever I have a repeated factor on the bottom. So let's say I had x minus 2 over x plus 1 cubed. In order to break this up properly, I would write it as a over x plus 1, and then b over x plus 1 squared, and then c over x plus 1 cubed. Whenever I have a repeated root, it has to show up to all of the powers less than or equal to that repetition. That's why since it was
The U minus one has U minus 1 to the 1 power, minus 1 to the second, and then it goes to the third,
fourth, it would be fourth, yeah. Now, the other way to do it is the worse way, is to say, oh, that is really an x cubed plus 3x squared plus 3x plus 1 on the bottom, right? If I multiply that out. So it should be ax squared plus bx plus c on the top, right? But then I'm going to have to try and refactor that to do the u substitution. Yeah. Isn't it a lot easier to try and do the substitutions here?
Yeah.
That's the reason we don't do it this way. It's possible, it just sucks more. And in any case, now that you know how to integrate, you'll get y and u. Then when you're done, we started with x was equal to uy, right? So everywhere you see a u, you're going to write x over y. Once you've finished doing the equation, your last step is to get rid of all the u's and put back in the x's and y's. You're welcome. I will be the first person to admit that if you didn't give me the massive hint of, hey, this is homogeneous, I wouldn't know what to do. So I'm very happy to have said, oh, you said homogeneous. My solution is either x over y or y over x. So that's what I'm going to run with. More questions? Okay.
Work out,
This is the one that says find the value of k.
Yeah.
Okay. 6xy squared plus cosine y dx equals 2k x squared y squared. Y is cubed. Oh, in the first part. Good catch. 6k x squared y squared minus x sine y. Oh, that's not an equal sign. That's a plus sign in the middle there. Plus sign equals 0. And we want to know how to make this equation exact, right? So to make this equation exact means that I need my to be equal to nx, where this part is m and this part is n. So let's start with partial derivatives. Take that first piece, take the derivative with respect to y. Okay, hang on a second. What's the derivative of that?
Oh. I'm totally bummed.
Okay, so if the y is cubed, that's going to give me 18x squared y squared, right? Because it'd be 3y squared from the y cubed. Oh, just x. Thank you. Hey, we're screwing up the exponents all over the place, you and me. I like this. Yeah, we'll as long as we keep catching each other. And then the derivative cosine, you're right, is minus sine y. Now let's go over to the n part. nx. nx is, what's the derivative of x squared? So that'll make it 4kx y squared. And then here, the derivative of x times sine y is just sine y, because I'm taking my derivative with x. The derivative of x is just 1. Okay, these parts match. So I need these parts to match. Oh, so 4k is equal to 18. K is 18 divided by 4, which is 9 over 2, which is 4.5. I just have to remember how to do all my partial derivatives to do this. And I have to copy down the exponents properly, otherwise we're in deep trouble. Oh, no. Did they say to actually solve it? No, they didn't say to solve it. Oh, I'm very happy about that. Yeah. If I put the right number in here, it's already exact. I don't need an integrating factor. Oh, thank goodness. Yes. 3-1 and 3-2. That's why you're handing in those homework assignments before we do this, so I can post the keys and you can have them. As you can see, I gave an exam earlier today. That's what the flames are for. Was the calc exam. Wow. Oh, hell no. I could have lied. Yeah, but I don't have that many pairs.
What is 24 or 2.5?
24 on 2.5. Solve by making an appropriate solution. 24. dy dx equals 1 minus x minus y over x plus y, right? Okay. I think we're going to try and make the substitution off the top. Because this is a linear thing, something x, something y, and a number. I'm going to do that for my u. U equals 1 minus x minus y. And if I do that, what's du dx? Notice I'm not doing the product rule differential here because I have dy dx. I want to get another dy dx. So what do I get here? Well, what's derivative of negative x with respect to x? And then minus dy dx. The first one, the derivative is 0.
I thought we would. So we treat it as a.
Yep. Well, but notice here the dx and the dy were separate, right? So I needed to be able to get rid of the dx and put stuff in u and y in its place. In your problem, dy and dx are together. So I want to keep them together, and I want to get a du dx in its place. Or something like a du dx. So I'll take my derivative with respect to x here. So I get du dx, the derivative of 1 is nothing, derivative of x is 1, derivative of y is dy dx. Okay. Now my goal is to take everything over there and have no more y in it, but to have u's wherever possible.
So you get a equation du dx, you have to manipulate it, so it's dy dx equals.
So if I put the dy dx over here, then it'll be -1 minus du dx. So this side is -1 minus du dx. Now let's look at the right side. The top is u. Because 1 over x minus y. That was what we used for u. What's the bottom?
Y. Y.
Well, let's use this right here. I have u equals 1 minus x minus y, right? I put the x plus y on this side. I get 1 minus u on that side. Wait a second. I'm going to make my life even better. Du dx with a minus sign is equal to 1 plus u over 1 minus u, right? But I can get a common denominator here. What does that turn this fraction into on top? Which means du dx, if I move the minus to the other side, is 1 over u minus 1. That's separable. I moved the minus sign, so I switched the order. U minus 1 du equals 1 dx. Whew. I know how to solve that now. And once I'm done integrating, I get rid of the u, put it all back in x and y.
So, wouldn't be like.
Okay. If I did u equals x plus y, then I would have du dx equals 1 plus dy dx. So far, so good. So on the right-hand side, dy dx equals 1 minus x minus y over x plus y becomes du dx minus 1, because I got to move the minus the over, And then this is 1 minus u over u. Right? Again, if I rearrange, I get a common denominator and nice things happen. And then I get a different, I get the same solution. It works. But it's just going to be a little different. So yes, you could absolutely use the bottom instead of the top. Okay, people. This is due tomorrow. Come see me in my office hours tomorrow morning if you have additional questions. Otherwise, I will see you then. I will post all the keys in the review sheet immediately after class tomorrow. A wonderful rest of the day.
Sounds good.